Welcome to the DIY Honda Garage channel. The diagnostic trouble code P2123 indicates a high voltage condition in the APP, Accelerator Pedal Position Sensor, A circuit, also known as TP Throttle Position Sensor D. This fault can affect the vehicle's throttle response, causing performance issues. The APP sensor is a critical component responsible for translating the driver's input on the accelerator pedal into an electronic signal that the Engine Control Module, ECM, or Powertrain Control Module, PCM, uses to regulate engine power. Typically located within the accelerator assembly, this sensor operates as a position transducer. The presence of this DTC indicates a malfunction that could lead to stalling or poor acceleration. Precautionary checks should include reviewing freeze data and onboard snapshots to diagnose the issue efficiently. The APP sensor A is responsible for measuring the position of the accelerator pedal. This measurement converts the mechanical pedal movement into an electronic signal sent to the ECM or PCM. The role of the ECM-PCM is crucial as it interprets this signal to manage throttle operation and ensure optimal engine performance. This component is typically situated near the accelerator pedal within the throttle body assembly. The high voltage indicated by DTC P2123 could signify an overvoltage condition or signal interference, which is essential to diagnose accurately. Therefore, pinpointed observations related to the connections and wiring of the sensor are necessary for revealing the root cause of this issue. Several factors can lead to the occurrence of DTC P2123. Firstly, poor connections at the APP sensor or associated wiring can disrupt the signal being sent to the ECM/PCM, leading to fluctuating voltage levels. Secondly, loose terminals can cause intermittent connectivity, where the electrical connection may be momentarily lost, resulting in erratic sensor readings. A faulty APP sensor itself could also be at fault, possibly due to internal wear or damage that affects its ability to read the position accurately. Additionally, issues with the ECM or PCM may arise, where a malfunctioning module may not interpret the signals correctly. Hence, understanding these causes is vital for effectively troubleshooting the code. The symptoms related to DTC P2123 can severely impact vehicle operation. One primary symptom is inconsistency in foot pedal response, where the engine may not accelerate as expected when the pedal is pressed. This could lead to delays in acceleration or sudden throttle changes, causing potential safety concerns. Additionally, general engine performance problems may arise, manifesting as rough idling or stalling, especially during acceleration. Drivers may also experience engine stalling, where the car momentarily cuts off unexpectedly, which can be particularly dangerous while driving. Recognizing these symptoms early can prompt timely diagnostics and repairs. The first step in troubleshooting DTC P2123 involves turning the ignition switch to the on position, specifically to II, where initial electrical components are activated. Following this, check the APP sensor A input using the HDS, which stands for Honda Diagnostic System, to read the sensor values in real time. At this moment, you want to determine if there is about 4.9 volts or more coming from the sensor. A voltage reading at or above this threshold indicates that the sensor may be functioning correctly at this point. If the voltage reading fails to meet this criterion, it suggests an intermittent failure, suggesting the system might be functional temporarily. This would lead to an examination of poor connections or loose terminals associated with the APP sensor and the ECM-PCM. The second troubleshooting step requires setting the ignition switch to the lock position, designated as 0. To ensure safety, while working on electrical components. Next, disconnect the APP sensor 6-pin connector, which houses multiple terminals crucial for the sensor's connections with the vehicle's computer systems. After disconnecting, return the ignition switch to the on position. 2. To allow voltage checks on the APP sensor wiring. Measure the voltage between terminal number 2 and number 3 on the 6-pin connector to see if it is about 5 volts. Achieving this voltage indicates a reliable connection and proper functioning of the sensor circuit. If the reading is below this specified voltage, further investigation into wiring and connections is warranted. In the third step of the troubleshooting process, repeat the act of placing the ignition switch in the lock position to ensure all systems are off for safety. The next action is to jump the SCS line using the HDS tool. SCS refers to the Service Check System, which helps in resetting the system for further tests. Following this, you will need to disconnect the ECM-PCM connector A, specifically the 49P model, to access terminals associated with the APP sensor and assess broader connections. Disconnection of the ECM-PCM is essential for isolating the sensor circuit from the control systems, allowing for a clearer assessment of the APP sensor performance independently. In the final troubleshooting step, begin by connecting APP sensor 6P connector terminal number 2 to body ground using a jumper wire. This ensures that we are testing for a solid ground path essential for normal sensor operation. Following this connection, check for continuity between terminal A36 on the ECM-PCM connector and the body ground. Continuity in this context refers to an unbroken electrical connection, necessary for the ECM-PCM to correctly receive signals from the APP sensor. If continuity is verified, it means that the signal can successfully return to the control unit without interruption. If continuity does not exist, it indicates a potential wiring issue that may be affecting the sensor's performance. After completing all necessary troubleshooting steps, it is crucial to verify the repair effectively. Begin by resetting the DTCs through the HDS to clear any previously stored trouble codes. Following the reset, conduct a road test of the vehicle to observe real-world driving conditions under various acceleration scenarios to ensure the vehicle responds correctly. During this test, monitor for any signs of the reoccurrence of the DTC or any irregularities in pedal response or engine performance. If the vehicle operates smoothly without returning to DTC P2123, it can be concluded that the repairs were successful. A thorough verification reduces the chances of recurring issues and ensures driver safety. To mitigate the risk of encountering DTC P2123 in the future, it is advisable to engage in regular preventive maintenance measures. Regularly inspecting connections and wiring associated with the APP sensor and ECM/PCM can help identify wear or damage early before they escalate into larger issues. Performing periodic electrical system checks can expose any voltage irregularities that may develop over time. Furthermore, maintaining clean sensor terminals is essential, as dirt and debris can hinder connectivity and affect performance. Establishing a consistent maintenance routine can extend the life of these components, ensuring optimal vehicle functionality and safety. In conclusion, DTC P2123 highlights a significant issue related to high voltage in the APP sensor A circuit, which plays a vital role in engine performance. Understanding the APP sensor's functionality and its connections can aid in rapidly diagnosing and rectifying the fault. Checking all wiring and connections is paramount, as many issues stem from simple electrical faults rather than complex sensor failures. Conducting thorough troubleshooting in systematic steps will enhance repair accuracy, while preventive maintenance practices can serve to curtail future occurrences of similar codes. Ultimately, embracing a structured approach toward diagnostics and repair leads to safer and more reliable Honda Accord performance. Please like and subscribe to the channel. See you next time.